Hi, welcome to the mathcenter.com. In this video, I'm going to talk about a commonly used phrase these days, flattening the curve. Yeah? The times that we live in and the pandemic, the Corona-19, the pandemic and so on, and people are using this line, or rather this phrase, flattening the curve. So many people have asked me what this means. So this is a overly simplified look at what flattening the curve means. It's for, I repeat, I haven't said it yet, but it's for non-mathematicians. I repeat, non-mathematicians. We can do a more complicated one, but I'm not going there. I'm going to use straight lines. I'm going to use straight lines to explain this idea, flattening the curve. So here I have drawn on the board a straight line, OA. OA is a straight line with the equation y equals to 3x. Now, this is the equation of the straight line. I'm giving you a couple of values here. When x equals to 2, y equals to 3 times 2, 6. That's this point here. Now when x equals to 3, y equals to 3 times 3, 9. So that's this point here. Now what's the point in this? What do you notice? When x goes up by 1, y goes up by 3. Again, when x goes up by 1, 2 to 3, y goes up by 9 minus 6, 3. And this is what we call in mathematics the gradient of the line. Okay, the gradient of the line. So the gradient is basically the amount by which y goes up when x goes up by 1 unit. Okay, great. So as you can see, for OA, as x goes up, y goes up. Okay? Now, before we go on any further, this number here, 3, in mathematics, we refer to it as dy dx. dy dx is the gradient function. This is a straight line, so the gradient doesn't change. So it's easier for me to talk about it. So what do you notice? As you go from 0 to 5, okay? As you go from 0, as x goes from 0 to 5, okay? Y goes up from 0 to 15. I repeat, when x goes up from 0 to 5, y goes up from 0 to 15. So here, x goes up, y goes up. Now this, we like to call it an increasing function in mathematics. Not important for us now, yeah? Okay? An increasing function. So an increasing function is when you have y increasing, when x goes up, y goes up. We call it an increasing function. Okay, good. Next point. What happens when you reach this point A? When you go from 5 to 6, I repeat, when you go from 5 to 6, there's no change in y. Y remains at 15. I repeat. When x goes from 5 to 6, remember from 0 to 5, when x was going up, y was going up. Now once it reaches 5, and then when x goes up by 1 unit here, y does not change. Y remains at 15. And as x goes from 6 to 7, y remains at 15. And this is the part we are saying here that the curve has flattened. Okay, the curve has flattened this portion here. That means when x goes up, there's no change to y. I repeat, let me write it here. Okay, x goes up. It goes up means when x increases. Okay, no change in y. Y remains the same. Yeah, no change in y. This part here. Okay, this is the part where we call flattening the curve. A few things I want to say. Now, this part here, x, we can consider it as as time. We can take x as time. This part here, y, we can take as the number infected. I repeat, we can take x as time, and y we can take it as number infected. So this portion of the curve OA is not really good, because when time goes up, we are saying that the number of infected goes up. Now, after this point A, then you find that when x goes up, the number of infected does not change. I repeat, the number of infected does not change. So we can think of this thing here, y as it, and this as t. So here we are saying that as time increases, the number of infected does not change. So we are saying that it has flattened out. That's good for us. This is the part that we are worried about. Okay, so let me tell you again, right? This is the part where we are talking about flattening the curve. I repeat, this is an overly simplified. Mathematically, those of you who are mathematically inclined, we like to deal with things like this. Let's say we're looking at the SIR model, the simplest model in studying pandemics, the simplest model. Then we have things like this, di dt, okay, equals to ASI minus BI. If this is known as a differential, I didn't go there. This is known as a differential equation. I didn't go there because then we have to do a little bit of solving of differential equations. Then we'll get an exponential function. Then you'll see things like this, yeah. Then you'll see things like this. You'll see things like this. You'll see things like this, yeah. Okay. This being your susceptibles. This talking about recoveries, and this one talking about infecteds. Okay. So some people like to call it infecteds. Some people like to call it infectives. Now I'm not going here because it becomes too mathematical. So let's leave that out. This part here is easier to follow. Okay. We are using straight lines. I'm telling you about what this whole thing means, the flattening of the curve. That means there are no more new infections. That's it. Okay, so I hope this has shed some light on the idea of flattening the curve. If you would like to read more about this, there's a lot of mathematics behind this. There are various models that they have used. You can look it up on the internet if you like, but this one I think will serve us as a very non-mathematical introduction to flattening the curve. Thank you very much for watching. I hope all of you guys stay safe. Thank you very much.